If you've got Windows and Linux living side by side on the same hard drive, here's the question you should be asking right now before you find out the hard way. Is your dual boot setup about to stop working? The short answer is maybe, and it depends entirely on details you've probably never had to think about before. The longer answer is the entire reason this question is suddenly everywhere on forums, Reddit threads, and tech YouTube channels this month. And it's worth understanding properly because the fix for most people is genuinely simple once you know what's actually going on. Now let's get into exactly why dual boot machines are at risk right now, who's actually affected, and precisely what to do about it before your computer makes the decision for you. Start with the mechanism, because understanding it is the difference between panicking unnecessarily and fixing this calmly in 10 minutes. Every modern PC that ships with Windows uses a security feature called UEFI Secure Boot. Think of it as a bouncer standing at the very first door your computer walks through when it powers on. Before any operating system, Windows, Linux, anything, is allowed to start loading, the firmware checks a cryptographic signature attached to the bootloader. If that signature matches a certificate the firmware already trusts, the system boots normally. If it doesn't match anything on the approved list, the boot process refuses to continue. This exists specifically to stop malware called bootkits from hijacking your computer at the lowest possible level before any antivirus software even wakes up. Real attack tools like Black Lotus have specifically targeted this exact layer in the past, so this isn't theoretical protection. Here's where Linux enters the picture and where the current trouble comes from. Linux distributions don't each have their own certificate baked into every motherboard sold on Earth. That would have required every PC manufacturer to individually trust Ubuntu, Fedora, Debian, and dozens of others by default, which was never realistic. Instead, Linux distros use a small translator program called shim, which is signed by Microsoft's own UEFI certificate authority. Because nearly every PC already trusts Microsoft's certificate out of the box, shim works as a middleman. Microsoft vouches for shim, and shim then vouches for the Linux bootloader, usually grub, and the Linux kernel itself. It's a clever workaround that's quietly kept Secure Boot compatible with Linux for over a decade, invisible to almost everyone who's ever dual booted. The certificate doing that vouching, the 2011 Microsoft UEFI Certificate Authority, is reaching the end of its usable life, and the transition to its replacement, the 2023 UEFI CA, is landing right now. After the cutover, new Secure Boot components signed only with the old 2011 certificate stop being trusted for fresh installs and updates, and the new shim binaries distributions are pushing out have to carry the new certificate's signature to keep working going forward. If your firmware hasn't been updated to trust that new certificate, certain Linux installs and updates can fail outright, and on a dual boot machine, that failure can leave you staring at a boot menu where Linux simply isn't there anymore, or worse, a system that won't reach either operating system cleanly until you intervene manually. Now for the question that actually matters to you. Are you affected? This breaks down into a few clear categories, and figuring out which one you're in takes about 5 minutes. If your dual boot setup is already installed, already working, and you're not planning to touch your bootloader or install anything new in the immediate future, you're in the lowest. Risk group. Existing, already trusted bootloaders don't suddenly stop working just because a calendar page turns. Boot components that were already signed and verified continue to be recognized by firmware that already trusts them. The danger isn't a ticking time bomb under a system that's currently fine. The danger shows up the moment you do something that touches the boot chain. Installing a new Linux distribution, updating grub after a kernel update, reinstalling shim packages, or setting up a brand new dual boot configuration on a machine whose firmware has never been updated. That's the actual trigger condition, not the date on the calendar by itself. If you fall into that trigger condition group, anyone planning a fresh install, a distro hop, or even a routine system update that touches bootloader packages, your risk level depends entirely on your hardware's age and whether its firmware has received the new certificate. Machines built in the last 5 or 6 years from major manufacturers like Dell, HP, Lenovo, and Fujitsu often either already have the 2023 certificate enrolled or can get it through a routine firmware update. Older machines, especially anything past its manufacturer's official support window, are the real risk pool. Some of that hardware will simply never receive a firmware update containing the new certificate because the manufacturer has no business reason to produce one for a product line they stopped supporting years ago. So here's what to actually do, broken into a clear sequence starting today. Step 1, check whether Secure Boot is even enabled on your system. On most Linux distributions, you can check this from a terminal, Ubuntu and Debian based. Systems can run Mochatil, SB-state, which will tell you directly whether Secure Boot is enabled or disabled. If it comes back disabled, none of this certificate transition affects your boot process at all, because Secure Boot isn't part of your boot chain to begin with. You lose some of the security protection Secure Boot provides, but you also sidestep this entire issue. If it's enabled, move to Step 2. Step 2. Check whether your firmware already has the newer 2023 Microsoft certificate. The most reliable way to do this without digging through firmware menus is the FWPD tool, which ships with most major Linux distributions already, or can be installed quickly if it doesn't. Running fupd-mgr get devices and fuupd-mgr get updates will check your specific hardware against a database of available firmware and tell you whether a secure boot certificate update is available for your machine. This single command sequence answers the most important question in this entire article for your specific computer. Step 3. If an update is available, install it, but don't do it blindly on a machine you depend on without a safety net first. There have been documented cases on certain hardware platforms, including some HP and Fujitsu models, where a standalone secure boot database update caused boot problems, which is exactly why those vendors have blocked the standalone update path on specific models and require a full firmware update from the manufacturer first. Before running FWPD-mgr update, check your manufacturer's support site for your exact model number and see if there's guidance specific to your hardware. If there's nothing flagged as risky for your model, proceed with the update through FWUPD. Step 4, and this is the one people skip and regret. Back up your data and create a bootable Linux Live USB before you touch anything. This costs you 15 minutes and a spare USB drive, and it is the single best insurance policy against anything going wrong during this transition. If a firmware update doesn't behave as expected, or a bootloader update gets applied at an inconvenient moment, a live USB gives you a way back into your system to fix configuration files, rerun grub install, adjust secure boot settings, or recover files, without needing to send the machine out for repair or lose anything irreplaceable. Do this before Step 3, not after something's already gone sideways. Step 5. If you're specifically planning a fresh Linux install or a distro hop in the near future, check whether your chosen distribution's current installer media uses a dual-signed shim, one signed with both the old 2011 certificate and the new 2023 certificate simultaneously. Major distributions have largely already handled this. Red Hat has pushed dual-signed shim updates for RHEL 8, 9, and 10 on x86 to 64 hardware, specifically to bridge this transition, and Canonical, Fedora, and other major maintainers have made equivalent moves. Dual-signed shim is the bridge technology making this whole transition survivable for most people. It works on older firmware that only trusts the 2011 key, and on newer firmware that only trusts the 2023 key, buying time for hardware to catch up. The risk shows up specifically with smaller, less actively maintained distributions that haven't caught up yet, where an installer might boot fine off a USB stick but fail to produce a properly bootable system afterward. If you're using anything outside the major, well-resourced distros, it's worth a quick search for your specific distro name plus shim plus 2023 certificate before you commit to an install. Step 6, specifically for existing dual boot users, handle updates in the right order. If you're updating both operating systems around this transition, the general guidance circulating among system administrators is to apply the relevant Windows side secure boot and servicing stack updates first before touching the Linux side. Doing this out of order, updating Linux bootloader components while Windows hasn't yet caught up on its half of the certificate handshake, has been the source of some of the messier failure reports, because the firmware level trust state can end up out of sync with what either operating system's bootloader expects. Step 7. For anyone running Linux inside a virtual machine rather than on bare metal, your situation is different and deserves separate attention. If you're running Linux inside Hyper-V, VMware, or KVM, your secure boot trust chain is managed by virtualized firmware rather than your physical motherboard, which is good news in the sense that virtual firmware is often easier to update than physical hardware firmware. But it's not automatic. VMware has published specific guidance for updating secure boot certificates inside vSphere environments. Microsoft is rolling out Hyper-V host-level patches to handle the transition for Windows-hosted VMs. KVM-based virtualization tends to require the most manual intervention of the three, often needing administrators to update the certificate database on each individual VM host by hand. If you're running a home lab with several KVM-based Linux VMs, this is entirely on you to handle, and it won't get fixed by anything happening automatically in the background. Now, an important reality check on how bad this actually gets in the worst case, because some of what's circulating online overstates the doomsday scenario, even on hardware that genuinely never receives the new certificate. Secure boot can be disabled in your firmware settings as a fallback option, which restores the ability to boot your existing operating systems. You just lose that specific layer of protection against boot-level malware while it's off. Your files don't vanish. Your Windows installation, in the vast majority of cases, keeps working fine throughout this transition. since Microsoft obviously has every incentive to avoid breaking its own operating system with its own certificate rollout. The pain is concentrated specifically around fresh installs, bootloader updates, and shim updates on hardware that hasn't received a firmware update, not around already working systems that nobody touches. The fix in the worst realistic case is go into firmware settings and disable secure boot, or apply a dual-signed shim once available. Not your computer is now a brick. That said, don't let the "it's not as bad as the scariest headlines" reassurance turn into an excuse to do nothing. The actual failure mode that's catching people off guard isn't some dramatic single-day event. It's the much more mundane scenario of someone running a routine system update weeks or months from now on a machine they haven't checked, and ending up with a Linux installation that suddenly won't boot with no obvious explanation at 11 p.m. on a weeknight. The entire value of reading this article today, instead of after that happens, is that the fix-it-now version of this problem takes 10 to 15 minutes and a calm afternoon. The fix-it-after version involves troubleshooting firmware settings menus you've never opened before, under time pressure, possibly without your usual computer to look up help on. If you manage more than just your own personal machine, say you're responsible for a handful of dual boot computers for family members, or you're an IT administrator handling a fleet that includes Linux machines alongside Windows, the same checklist applies per machine, but it's worth doing a hardware inventory first, rather than discovering gaps one support ticket at a time. Catalog. Which device models in your environment have received OEM firmware? Updates containing the 2023 certificate, and which haven't, since Dell, HP, Lenovo, and Fujitsu have all rolled these out on different timelines. And don't assume Windows Update is silently handling the Linux side of this for you. It isn't, and it was never designed to. For legacy hardware that's reached end of service from the manufacturer's perspective and has no compatible firmware update coming, the honest long-term answer is either planned replacement or accepting a gradually increasing security exposure as future secure boot revisions, designed to counter newer bootkit threats, become unavailable to that specific hardware going forward. One more practical tip worth building into your routine going forward, not just for this specific transition: keep that bootable Linux live at USB around permanently, not just for this month. Certificate transitions, like this one, aren't a one-time event. They're a recurring fact of how cryptographic trust infrastructure works, the same way SSL certificates for websites expire and need periodic renewal. The 2011 to 2023 transition is happening now. There will be another one eventually, on a timeline nobody's announced yet. Having a recovery USB on hand, a recent backup of anything irreplaceable, and a basic comfort. Level with checking Mochatil and FWAPDMGR output isn't just a fix for this specific news cycle. It's the kind of low-effort habit that makes the next certificate transition a non-event instead of a scramble. So, to bring this all back to the question in the headline, is dual boot breaking this month? For most people running modern hardware who aren't actively changing their bootloader setup, no, not in any way you'll notice, without going looking for it. For people planning a fresh install, a distro hop, or a routine update that touches grub or shim on older or unsupported hardware, the risk is real and worth 10 minutes of checking before you proceed. The difference between those two outcomes isn't luck. It's whether you ran Mochatil, SB State, and FWPDMGR get updates this week, backed up your data, made a recovery USB, and updated your firmware if one was available, or whether you found out you needed to do all of that at midnight with a system that won't boot. Do the checklist now. It's genuinely the entire difference. Let's walk through a few specific scenarios people keep asking about, because the general checklist above doesn't always map cleanly onto someone's actual situation. I just want to keep my current dual boot setup exactly as it is and never touch it. This is genuinely the lowest risk position to be in. If you don't install new software that touches the bootloader, don't run a major kernel update that triggers a grub reinstall, and don't manually update shim packages, your existing boot chain stays trusted. The one thing worth doing even in this scenario is still checking your secure boot status and firmware certificate situation, just so you know where you stand. Not because you need to act on it immediately, but because do nothing is a much safer choice when it's a deliberate decision rather than an accident of not knowing your options. I'm planning to install a new Linux distro on a dual boot machine in the next few weeks. This is the highest attention scenario, and it's worth doing the full checklist before you start. Confirm secure boot status, confirm or update your firmware certificate, confirm your target distro ships a dual signed shim in its current installer, back up your data, and make a recovery USB of your current working system before you begin. If your chosen distribution is one of the major, well-resourced ones, Ubuntu, Fedora, Debian, OpenSUSE, RHEL, and its derivatives, you're very likely fine, since these projects have had engineering resources specifically pointed at this transition for months, If you're going with something smaller or less actively maintained, spend 5 minutes searching for that distro's name alongside 2023 certificate, or shim, before you commit your time to an install that might not boot cleanly afterward. My system updated automatically, and now Linux won't boot. What do I do right now? First, don't panic. This is recoverable in the overwhelming majority of cases. Boot from a Linux Live USB, which is exactly why step 4 above told you to make one in advance. From the live environment, you can mount your existing Linux installation, check whether the issue is a secure boot trust failure or something unrelated, and in many cases, simply reinstalling Grub or re-enrolling the correct certificate through Mochatil from the live session will restore normal booting. If you don't have a live USB ready, you can typically still get into your firmware settings menu, usually by pressing a key like F2, F10, F12, Del, or ESC during startup. Check your manufacturer's documentation for the exact key, and disable Secure Boot entirely as an emergency fallback to get back into your system, after which you can create that live USB and address the underlying certificate issue properly. I don't know if my firmware even supports the new certificate, and the manufacturer hasn't said anything. This is the trickiest category, and unfortunately the honest answer is that some hardware is going to fall through the cracks here, particularly anything that's already passed its official manufacturer support window. Check your manufacturer's support site directly for your exact model number rather than relying on general assumptions about your hardware's age. Sometimes firmware updates land for surprisingly old models if there's enough installed base to justify the engineering work. And sometimes newer models get cut off sooner than you'd expect because of a specific chipset limitation. If nothing is available and nothing is coming, your fallback plan is the same one available to everyone. Disable Secure Boot in firmware settings when you need to install or update boot components, accept the reduced protection against boot-level malware, and treat replacing that hardware as a when it makes sense decision rather than a right-now emergency, since the practical risk of running with Secure Boot off is still much smaller than most people assume for a typical home or small business use case. It's also worth saying plainly what this transition is not, because some of the framing circulating online blurs the line between a real, specific, fixable problem and a vague sense that something with Linux is permanently and mysteriously broken. This isn't malware, it's not a virus, and it's not evidence that your computer has been compromised. It's not a sign that your specific files or data are at risk in some general sense. The entire issue lives in a narrow, well-understood layer of the boot process, and once you've checked your status and applied the available fixes, there's nothing further lurking that needs ongoing vigilance beyond the same basic hygiene you'd already want to practice, keeping backups current and your system updated. Treating this as a contained, well-documented infrastructure transition rather than an ominous mystery is the accurate way to think about it, and it's also simply the calmer and more useful way to approach fixing it. If there's one habit worth carrying forward past this specific news cycle, it's this. The next time you're about to do a fresh Linux install, a major distro upgrade, or any operation that touches your bootloader on a dual boot machine, make checking your Secure Boot and firmware certificate status a standard first step, the same way you'd already check that you have a current backup before doing anything risky to a drive. This particular certificate transition will pass. Most affected hardware will get its firmware update. Most distributions will finish rolling out dual-signed shim packages, and within a year or so, this will be a settled non-issue for the overwhelming majority of dual boot users. But the underlying pattern, where Linux's secure boot trust depends on a certificate chain that periodically needs renewing, isn't going away. Building the habit now means the next transition, whenever it comes, is a 5-minute check instead of a forum-fueled scramble. A few quick answers to the questions that come up most in the comment sections of every article like this one. Does this affect Chromebooks running Linux through Crostini or a similar container? No, that's a fundamentally different boot architecture E managed by Chrome OS itself, not a UEFI secure boot chain in the traditional sense, so this specific transition doesn't apply. Does this affect Macs running Linux? Apple Silicon and older Intel Macs use their own boot security models rather than standard PC UEFI secure boot, so the Microsoft certificate transition described here is specific to PC class hardware running Windows-compatible firmware. Mac users running Linux through Asahi or Boot Camp are dealing with an entirely separate set of considerations. Will this happen again? Almost certainly, on some future timeline, because certificate-based trust systems are built to expire and renew by design. The responsible move is treating check my boot security status as a periodic 5-minute habit rather than a one-time fire drill. And finally, is there anything you should do if you're not even sure your machine is dual boot or has secure boot at all? Yes, Run Maucatil SB state if you're already in Linux, or check your firmware settings menu directly during startup if you're not sure. Because I don't know is the one answer in this entire situation that's worth turning into a definite yes or no before you do anything else with your computer this month.